Welcome back to the show. I'm here with Brian Cass, and he is speaking at CF.Objective in a few days' time about how you can level up your web apps with Amazon Web Services. And before you yawn, there's so many things in Amazon Web Services you probably didn't even know are there. And we will talk a bit about that and all the amazing things you can do with S3 storage. And he is going to be demoing at CF.Objective how you can use ColdFusion and Node.js microservices to invoke in an on-demand way. So you can use AWS Lambda, and we'll talk about what that is. And also we've got some artificial intelligence stuff you can call from your app as well, which is processing images using a thing called Reflektor. And we'll also look at some NoSQL datastore using DynamoDB. And he's going to be talking about common problems you can avoid when you're dealing with cloud service providers. So a whole bunch of interesting stuff for modern web app development. Welcome, Brian.
Thank you. Thank you, Michael, very much.
So let's just start off. You know, people think they probably know what Amazon Web Services is, but there's actually more to it than you might think, right? Tell us what it is and why we should be paying attention to it.
Absolutely. So, I think for most developers, their introduction to Amazon Web Services was or is a service known as EC2, which is Elastic Compute Cloud. That's their vast array of virtualized servers that come in all sorts of shapes and sizes and memory and speed and all that stuff. And a lot of people say, oh, we're going to move stuff out of our data center onto AWS, right? And by that, they mean they're going to run their on-demand applications, their custom apps, their licensed apps inside of AWS's computing center or centers, so that they don't have to run their own data center, because nobody wants to run servers. It's incredibly boring. Well, that is actually the most boring part of AWS. AWS has expanded so much in the last 3-4 years into now it's, I think, I can't even actually fit all the services on one slide anymore. I used to have this slide at the beginning of my presentation with all these rows of boxes and boxes and boxes and boxes. I can't fit all the services on there anymore because they're all about sort of, in some ways, on-demand compute, on-demand infrastructure, but they're really about foundational building blocks that can make your life as an application developer, not just a web app developer, but an application developer for mobile, for desktop, for the web, and even sort of system applications a whole lot easier. And I know I sound like an AWS fanboy when I talk about this stuff, but I could not build this stuff myself, right? I can tap into it and I can use it and I can provide so much better services for my customers because I'm using it than trying to go out and do it on my own. I mean, there's no point in reinventing the wheel when they don't always do a great job. The wheel's a little rickety in the first release, but it provides me with a whole set of services there's no way I could have the expertise to build or even hire the expertise on my own to build. And so I pay AWS pretty low prices to tap into all these services, and we get some fun stuff out of it in return.
And this isn't just one wheel, right? There's they have 40 different services.
Right. Exactly. And when I talk about it, like I'm going to be talking at CF.Objective, it's hard to cover everything because you couldn't. I mean, they have a conference called reInvent that lasts 5 days, and there are over 500 sessions, and they can't cover everything in those 500 sessions. 500
sessions just on Amazon Web Services.
Absolutely. And that doesn't even cover all the stuff they do. They leave whole sessions, whole services out because they're less interesting or they're not the right audience. And the conference is insane. This year they're expecting 40,000 people. Last year was 34,000 people. It's bonkers. It takes over Vegas for a week in November, but it's really fun. And I always learn a lot at that conference, which is kind of cool to plug that.
Right. Just trying to understand how you combine Vegas with AWS.
Right.
And you go to the roulette table and it's all running some service or whatever.
Exactly. I don't know. I'm sure some of the casinos have their workloads in AWS as well. So it's a little bit crazy.
I imagine.
But it's fun because it
so
allows
what are some of the highlights of these different things that are now in AWS that we may not have come across?
So I think, one that I always start talking about because it's easy and accessible to people is S3 or Simple Storage Service, which is this sort of infinite
Hmm.
file system for the web. And lots of companies use it. I mean, everyone from Instagram to, our shop, and everything in between uses it to put documents, files, photos, images, videos, because it's super fast and super cheap. We store about 4 terabytes of data in S3. These are just files, objects, customer files, our files,
Hmm.
content we create. We store about 4 terabytes and we pay $34 a month for that, something like that. And it's
No
replicated.
way. Really?
Replicated in 3 different data centers. It's accessible from anywhere in the globe. It's incredibly fast because you're going over Amazon's private network, behind the scenes out to the public internet. And a lot of people serve static websites or regular websites off of S3 because it's so cheap to do it and to host all that content there. So I usually talk about that because it's fast, simple, cheap, and there's support for it built into both the ColdFusion engines, both Adobe ColdFusion and Lucee have had support for S3 for years, where you just, instead of a location on your C drive, you type in S3:// and it passes your file, and ColdFusion figures the rest of it out. And all the ColdFusion functions, like file-related functions, work with it out of the box with no modification, which is very nice for doing, again, rapid development, which is something that ColdFusion has always excelled at. So I usually start with S3, but then there are a whole bunch of other services, and the ones that I talk about are ones that we use because you should talk about stuff that you're doing, right? And what works and what doesn't. And so there's really 3 ones that we're using right now on top of S3, on top of the Elastic Compute Cloud, because we do some stuff with that as well. And those services are Lambda and Recognition, but that's part of a larger thing I'm going to talk about, which is step functions, and also DynamoDB, which is their NoSQL solution. So those are the ones I talk about here, but I could go on and on about a whole bunch of other services that they offer that we don't use a lot of, that we want to use, play around with. If we want to do like data lakes, we might use something like Redshift, or if we wanted to stream all of our logs to them for real-time analysis, we could use a tool called Kinesis. And these are all things we played with, but haven't yet developed production apps around.
Well, you're just going to have to go to reInvent, because I just put the website up and put it in the show notes, and I discovered it's
Excellent.
not 500 sessions, Brian. It's 1,000 sessions.
Is it really? Okay.
Yeah.
You get to see it gets bigger and bigger.
So I don't know how. Yeah, I don't know how you're going to attend 1,000 sessions in a week. You're going to have to multitask yourself.
My feet hurt so bad last year from walking from the Venetian Convention Center to the Mirage Convention Center, back and forth, back and forth. And that's like literally a mile walk from one convention center to the other, because it's the ends of these resorts. This year, it's spread between like the Venetian, the Mirage, and all the way down to the Aria and the MGM Grand, which are like 2 miles down the strip. So I don't know how that's going to work out, but I can tell you it's not going to be good for my feet.
I only have one word to say, and that's segue.
The Segway, exactly. Let's have an army of them. For all you register, you pick up your Segway, and there'll be 40,000 Segways going through the streets of Vegas. That won't end in disaster.
No. So you mentioned you use S3 in your apps just to be able to store data, or what kind of things are you storing in there?
So it's not a database, although they actually have tools where you could store a comma-separated file in there, or log files, and use their tools. They have a couple ones called Athena, where you can actually write queries against data stored in sort of structured text files inside of S3. And some people do that because they put like log files in there. We primarily store fun things like videos and images and Word docs and PowerPoint and Excel and all the sort of user-generated content that we generate in our applications, or I should say our customers generate in their applications. That's what we store in S3, because we don't have to worry about file storage, and we don't have to worry about replication, and we don't have to worry about speed at which this will be there. And honestly, we can leave files in there for 10 or 15 years if we want. And one of the cool things about S3 is they have a limited amount of lifecycle sort of policies that you can add. So you can say that after, if this file hasn't been accessed in more than 180 days, move it off into long-term storage where it's not immediate retrieval. It might take a few hours for you to put a request in and get the file back, but it saves you tons of money. That way, if you have compliance sort of requirements that say, yeah, you have to keep this data around for 15 years or 10 years, like we do, we have to keep our data around for 10 years to comply with student information laws. We know it's not going to get accessed, but we have to keep it somewhere. And rather than building out file systems that are all equivalent, we can say, hey, just automatically after 180 days, move it off into the long-term storage so that we don't have to worry about that and do that work ourselves. So I mean, there's some life cycle built in. It's not really complicated, but it's certainly very handy and makes working with S3 even that much more pleasurable, at least for us.
Great. And is that long-term storage Amazon Glacier or something else? Or?
Yeah, that's Glacier. Yeah.
So they're basic Glacier. Yeah. All right. Well, you say Glacier.
I know. That damn hard American accent. Right? Yeah, exactly. Tomato. My mother says tomato, but that's because she grew up in South Africa. So.
Oh.
And she never got rid of it. She's lived here for 50-some years, and she still says tomato and aunt instead of aunt. She rags on us all the time when we say ant or potato or tomato. Doesn't like it.
But this Amazon Glacier or Glacier, it basically copies it off onto tape, and then they have a little robot that picks up the tapes and loads it back on. Or
pretty much, yeah. And
but you don't have to care about that.
Right. Exactly. That's the great thing. That's the reason I like working about AWS is you don't have to worry about what's going on behind the scenes. You just build, and you let them take care of all those details, which are annoying and difficult and problematic. And again, I couldn't build a robot army with my limited time, resources, and staff, and Amazon can build one that will take a tape off of here and put it over there and do all that stuff. They're good at that. I'm not good at that.
Makes sense to use things like that. So you mentioned Recognition was another service you use.
Yeah.
What does that do for you? Is that this AI thing?
It is. So Recognition is one of Amazon's many, not many, there's a growing army of AI tools. So they have AI tools that power the Amazon Echo. Or talk to Alexa, I should say talk to Alexa, right? Whether it's on our phone or it's on our Echo or whatever it is. They have speech recognition services you can tap into. They have text to speech. So you could say, here's a document and read it aloud in the Amazon Alexa voice if you want to do that. And Recognition is their image AI, computer vision sort of tool. I shouldn't call it computer vision. I should say it's image recognition services. So Recognition can do things like you upload a photo and it can scan that photo for faces, which seems pretty straightforward. But it can scan the photo for faces and also tell you basic age range, sex, if they're wearing glasses, if they're happy, if they're sad, sentiment analysis, things like that. It can do face matching, and this is something that we're actually doing. So we have requirements about identity verification when students take classes, and we offer lots of classes online and at a distance. And one of the things the law requires, federal law says, the person taking the class or taking an exam is really supposed to be the person who's signed up for the class, not have some random person take your test, right? You could do it at a distance. Nobody would know because you're never in class. So one of the things that we built is using Recognition is a tool that basically when you start an exam or start a test, it scans your face. You have to have a video camera. It does, basic JavaScript using the camera API, takes a picture of your face, and then compares that to an ID that you have had taken at some point in the past, because all of our students have to at least have like a picture ID that's on file with the university. That's your official photo with the university, usually from something like a driver's license, passport, something like that. And so what we can use Recognition to do is say, is this photo that you provided us a long time ago the same person as this photo, which is on the camera right now, because it does image matching and gives you a confidence score that says that anywhere from 0 to 100% that these are the same people. And it works surprisingly well. I mean, there's certain things it doesn't do so good around, like if the one photo has no sunglasses and this one has sunglasses, it has a problem with that. But we just say, look, you have to have your sunglasses off. But the matching, I've done, I've done tests with myself, for example, where it's a picture from me from 15 years ago and today, and it matches it.
No,
This is the
really?
same person. Yeah. It's kind of cool. And I've done it with like my kids where pictures from them 5 years ago versus today. And it's like, yeah, it's the same person. It's really quite good at that. And so that's what we're using it for. But there's another feature you can use it for is for labeling images. So if you wanted, they actually use recognition for Amazon's own cloud storage search. So if you store your photos in Amazon cloud storage or photo storage, and
Picasa, I believe it's called, right?
Right. Well, no, I think it's Google. I think Google's Picasa. I think.
Oh, okay.
Amazon
has
has
the same feature in Google.
Right, exactly.
Amazon
so it's
Photos,
the same. Sort of
maybe
feature.
that's what
Amazon
it is.
Photos. Thank you, Michael. That's exactly what it is. So if you search for dog, it will use the same technology to scan through all those photos and look for images with a label of dog. And you can tap into this for yourself. So if you want to do an inventory of clothing, you could say, instead of someone manually going through and saying labeling all the, the colors of the pieces of clothing or the style or whatever, you could tap into Amazon's system, and there are many labels to come up with a classification system for that. So it's actually quite powerful. It's quite fast and really quite, again, fun and easy to use using, for all of these things, we use their Java SDK. So everyone knows who works in CFML, it's built on top of Java. So we drop the AWS SDK for Java into our lib directory in our CFML engine, and we have access to all of those services directly from ColdFusion. It's more Java-like, right? It's not nicely wrapped in tags, but it's very easy to read, very easy to use. It takes very little time to rip out these services and rip out these new features because we're using all that stuff that's been done for us in the Java SDK from the get-go. Same thing works for Python. Python has a very robust library called Boto, B-O-T-O, that you can use if you're a Python developer as well.
So you mentioned also that you're using Reflektor for image stuff.
Right. So that's
what is that doing?
Right, that's the image library for that I was just talking about. Reflektor is the name of their image library.
Okay.
I don't know. I guess reflection has to do with images and stuff like that. So they have three main libraries for AI: Poly, which is the text to speech; Reflektor, which is image recognition and search and sort of data labeling; and then Lex, which is their natural language processing that they use for Alexa and the Amazon Echo. And those are all available to developers. We're only using recognition right now.
Wow. So if you wanted to create an Alexa, you could effectively code it using all this stuff.
Pretty much, you'd use the Lex library to, and that you can actually go out and do this now if you want to. They have lots of tutorials on their website that talk about like how do you set up a chat bot, how do you set up voice recognition. So it like looks for a very specific tool, like they call intents and slots. For an intent would be something like order a cup of coffee, and a slot would be the size of the coffee cup and all the different options that go in there. And that's all stuff that they have on there right now on their website. We just haven't found an opportunity yet to use this in a real production app.
Yeah, my mind boggles at the thought of having apps
having that much power, right?
Right.
The great
they
thing.
could talk to you and
yeah, you can, and you don't have to worry. The great thing, again, you don't have to worry about the infrastructure. It's just there, and you can build your apps that you need to build on top of it, knowing that the underlying technology just works and is there for you.
And unless they have one of those outages that
there is
a month or two ago, right?
Yes, the great S3 outage of February 2017, which I will talk about in my presentation. So that is one of the challenges with dealing with AWS or IBM Bluemix or Azure. Microsoft Azure services or Google Cloud Platform is that stuff goes wrong. Once in a while, there are outages. So we've been using AWS for a long time. Like I think it's been about 6 years now, at least starting with S3 and then moving on to other services. And the outages are much less common than they used to be, but stuff still happens. And that's something you have to plan for. You have to have a strategy for it. But the real question, I think, depending on the size and scope of your business, is that people talk about redundancy in multiple cloud platforms and all that good stuff, is what's the loss going to be? What's the cost going to be for you to have downtime because of these cloud services that might happen? In this case, that was the first outage in S3 in almost 4 years. So do you want to pay for the cost of rebuilding everything in another provider, having redundancy in multiple Amazon regions around the globe, whatever it is, and all of that cost for an outage that may last, 2-3 hours? On one day every 4 years. And I think that's the sort of, people get freaked out about the cloud and what it might cost, but I think that's the real business question that has to be asked when you're looking at cloud providers and redundancy and dealing with outages. This is what's the real actual cost to your business. For an Amazon itself, right, for a shopping website that does super high transaction volume, it's not acceptable. But you probably in those cases have the resources to do all this work, right, to this redundancy and be on.
Well, and doesn't Amazon eat their own dog food? I mean,
Absolutely.
Don't they use S3 themselves? So when that went down, they were screwed.
Right, exactly. So every single service that Amazon builds, they have built every single AWS service that is provided, Amazon has built and used for themselves internally first. So they use every single one of these services. Like I said, the Echo, Amazon Echo and Dot, the Alexa service is powered by Amazon Lex and Amazon Poly. So these are services they'd already been using, for quite some time in the background before they let us do it. So they use S3 and they use DynamoDB and they use Lambda and they use CloudFront, which is their global content distribution network. They use Kinesis for real-time data streams, and they use Elasticsearch for doing internal search of unstructured data. They do all of these things themselves internally, and then they make it available to the public for use. So yeah, they dog food their own stuff in a very, very serious way.
Yeah, so that gives me a lot more confidence that any promise someone can make in an SLA.
Right, absolutely. It's like they're Amazon. If S3 goes down, like you said, they're screwed. They're going to lose a lot of money too.
So you mentioned creating microservices that you call from ColdFusion that are invoking on-demand Node.js to run those microservices. Tell us a bit more about what you're going to be demoing there.
So one of the, as a CFML developer, one of the things I think you should try to do, that you need to be doing to be a better developer over time, is use other languages, right? Whether it's JavaScript, whether it's Python, whether it's .NET, whatever it is you're going to be using, use something other than pure CF. Even if it's just Java and dripping down the Java, use something else. And when the Node bandwagon started blowing up a couple years ago, and everyone's like, Node's the best thing ever, get rid of CF, it was like, well, no, we're not going to get rid of our investment in CF because it's huge and important to us, and CF actually makes us productive people, productive developers. But we want to try out this Node thing. We can see where there's value. We can see the high I/O throughput. There are things that, and it even just to play around with it. Cool, great. Around the same time as Node was sort of coming on the rise, there was also the rise of microservices, right? Everyone's like, get rid of your monolith, redo everything in microservices no matter what, regardless of what your architecture is. And that's great for, Uber and Netflix and everyone else, but it doesn't quite work that way. And then for many people, the journey to microservices is a gradual and progressive one, and should be one. And AWS came out with this tool called Lambda, the service called Lambda. It was the first, what do they call it? A serverless, right? Functions as a service. So it was the birth of the serverless movement in a very real way, where the idea was there's not even servers you worry about. So with EC2, you have to manage and maintain a server, whether it's a Windows or Linux server, you got to maintain that. With Lambda, you just write code and it just magically runs, right? So what's actually happening in the background is, yes, there are servers. They're spinning up Docker containers with node runtimes where your code's being dynamically loaded in. Yes, there are servers, but you don't worry about it. You just write functions. And the functions respond to requests and they send stuff back and respond to requests. You don't have to worry about servers. So it's really cool. So if you need to invoke the same function on 10,000 images, you don't have to build up a task management queuing system to do that. You don't have to build up a farm of servers to do that. You just say, here's 10,000 images, go. And Lambda handles the rest of it. And we use Lambda for a number of different things, but probably the most interesting thing we use it for is a whole automated video encoding, transcoding, and transcription workflow. So I work for Johns Hopkins Public Health. We're an education institution. We do a lot of video in our classes. And this video has to be delivered, as we all know, on the web. You can't just put up an MP4 file. It's got to be in different sizes, at different bit rates, WebM for people who don't have MP4 support on their Android phones, and we got to caption and transcribe these things for accessibility reasons, for universal design reasons, really. And we could do all that by hand, and that would be terrible. But so what we're using instead is we're using Lambda as a workflow center, workflow hub. So we wrote these scripts that are all tied together in Lambda. So we drop off a video in S3. Lambda listens for those events, runs some code that does some prep work, IDs it, tags it, stores that information in DynamoDB, which is their NoSQL database, and then also calls another service called Elastic Transcoder. And Elastic Transcoder is a service they've used for a number of years. It's the heart of Amazon Video that takes video and transcodes it into all sorts of formats, or audio and transcodes it into all sorts of formats. And it transcodes it, our source video, into all the formats we need. Each of those get dumped off back into S3. The same Lambda function listens for that and says, oh, this is a drop-off. Let me update this information in the database table. When all the different versions are all done, Lambda knows for that, listens for this, checks it, marks it off in the database, talks back to our ColdFusion application through a webhook, and says, hey, this is now published and available for students to consume. And all we have to do, my team has to do, is literally move that file into a launching point in S3, and we're done. Or our application can do that. That's actually what we have it doing. Somebody uploads a file through the app. All that other work, which can take hours and hours and hours to do, because video transcoding can be a very time-consuming and intensive process, we don't worry about it. It's all handled through this server, and we don't run any servers. We don't run any video encoding servers or anything like that. We just say, Lambda, do your magic. And that's it. And the code for it wasn't really difficult to write. It was all written in Node using existing libraries, the AWS SDK for JavaScript, which runs inside of Node, and some other libraries there. Promises to make our life easier, because promises always make life easier in programming. And it was great. And it didn't happen overnight. And it's probably the most complicated example of what we do in Lambda. But the great thing about Lambda is that A, we don't run servers. B, any kind of like asynchronous batch processing task thing that we want to do, we're really moving to Lambda now, because it lets us build a node. It lets us work in that environment. And it's really easy for ColdFusion to talk to Lambda and to launch these services and get data back through the AWS SDK for Java. So it's really nice, because now we're both Node developers and CFML developers without running a single Node server ourselves. And that's one of the really cool things about Lambda.
That is cool. So this takes the whole Docker revolution to another level.
Absolutely.
You don't even have to provision the Docker containers,
right?
Let alone the servers underneath.
Right. Lambda does all that for you. You just plug your code in there and you're done. And it's pretty darn cool.
I'm wondering what the next step in this progression is. No servers, no containers,
no functions, right?
Yeah, exactly. I'm wondering if you just tell Echo, Amazon Alexa, whatever, yeah, I want that function for this, and it goes off and writes the function and runs it in a Lambda.
I mean, with AI is writing its own programs, its own languages. It could, that may not be a too far out possibility.
Yes, maybe the movie Terminator had it wrong. Maybe it won't be a violent end. Maybe it'll just be a lot of software being developed.
That's right, exactly. We'll all just sit back maybe it was more like WALL-E, right? We'll all just get really big and fat and from not having to do anything, because AI takes care of everything for us. We'll have our giant sippy cups. That'll be great.
So you also mentioned you use a NoSQL database. I guess I don't know if database is the right word for that. Data store,
document data store,
DynamoDB that document data store. So
right.
What are you using that for? And tell us about how you do that.
Well, so again, for DynamoDB is AWS's NoSQL data store. And instead of running our own Mongo cluster or CouchDB or something like that, again, because I'm not big into running servers is not fun, at least not for me and my team. And we don't have the resources to really do it. But again, there are use cases in which NoSQL databases are great. I'm not a huge fan of NoSQL databases, in part because I think they're overused for things that certainly modern relational databases could handle much better. A thing like Postgres, I think, is awesome at so many things that people try to use something like Mongo for, especially with its JSON, its native JSON support. Now, I think SQL Server 2016 has native JSON support as well. So not always the best uses for it. But where we're using DynamoDB for is, is for capturing data streams, unstructured data. So for one thing, an example of how we're doing this is that we do data analysis of what students are doing when they're taking exams, to see like, how much scrolling are they doing? How often do they change their answers? Depending on the length of the exam, how long do they generally average stay on the page? And looking at the data, the clicks that come in, the scrolls that come in, all that sort of event data from the browser, all that event JavaScript-based sort of event browser data, what scrolling XY locations, what they clicked on, what all that good stuff, and additional data on top of that, like their IDs and what question ID and what answer ID and all that fun stuff. So we can do analysis on this and see what are the real behavior patterns within a given course or across courses when students are taking exams, because this is information faculty want to know. But as we're doing this, we're like, well, a traditional relational database won't be a good data store for this, right? Because we're going to be generating way too many events way too fast. All those inserts would just wind up killing a single table, and if you're trying to join it across tables, we have to know our document structure ahead of time. And a lot of times when we're doing this kind of research work, we don't know all the attributes we want to include. And so a document data store is great for that because it's flexible, right? We can say, the first million requests that came in didn't have attributes X, Y, and Z, but the second 10 million or the next 10 million did have attributes X, Y, and Z, but we dropped A and B because they weren't really interesting to us. So, we don't use Dynamo as a long-term data store. It's really like a good place for us to do some basic querying, some basic capturing of data. I think that it's possible, I mentioned earlier on, there's a tool called Athena that can query CSV files, and it's possible we may shift into doing more of that in CSV files. But again, CSV files have to be structured in some way so that the querying engine knows that the third column is, the country column, or the fifth column is the day on which this event happened. It's nice to have unstructured data and nice to have that flexibility. And for us, that's really where Dynamo comes in, is when we need to capture data in a not so structured way. So yeah, we still use relational databases. We'll never, I can't say never, but probably never stop using them. But DynamoDB is another nice add-on on top of that. And what's really nice is it's extremely high throughput. You can literally do, if you want to, hundreds of thousands of inserts per second. We don't pay for that because that's way too expensive. But for our purposes, it's very fast and very flexible. And again, we're not running our own servers. We use the same SDK that we use for everything else, all the other work that we use, rather than learning a new set of technologies and a new set of SDKs to access that content.
So basically you decided to use DynamoDB instead of MongoDB because it was part of AWS and it was all integrated in.
Pretty much. I mean, that's sort of the vendor lock-in people keep warning you about, right? But for us, there was no compelling reason to set up our own Mongo cluster or even to use the many services that are out there that provide that service for you. It's like, look, we're already doing it inside of our CFML app. We're already using the AWS SDK. We're familiar with the whole permissions model. Let's go ahead and use that. And it's a very simple tool compared to some of the things you can do in Mongo. It has its own version of like the aggregations framework, and you can do some somewhat advanced querying, not quite like Mongo, but then again, the data that we're putting in there right now for us is not so mission critical that we need incredibly robust aggregation frameworks or anything like that to query against it.
And is it distributed as well if you want to have redundancy? And
the redundancy is already built in. You can do cross what they call region replication. So every AWS has now, I think it's I want to say 18 data centers around the globe, and within each data center, or what they call regions, geographically distributed all over the world. Within each region, they actually have 3 physical data centers. So, for example, US East is the first one they set up. It's in Northern Virginia. But it's not one building. It is 3 separate buildings within about 5 miles of each other that is all considered to be one region. So when you say, so each building was what they call an availability zone. So within a tool like Dynamo, you automatically get replication across availability zones, meaning in case one building were to blow up or one building were to lose power, your data would automatically be replicated in those 2 other buildings, which are about 5 miles apart. If you want to go one step further, you can replicate data across regions so that if you have lots of people in China, they're accessing the China region rather than the Virginia region. It costs a lot more. There's a lot more complexity in terms of that setup because you're basically doubling all of your costs, doubling your use of all the services. But it is certainly an option. And companies like Netflix, the reason why they're so amazing and widespread and truly global is because they use data centers in every single one of AWS's regions, plus their own sort of hardware in ISPs around the globe.
Mm. It's mind-boggling how much time and money that must have cost to build those data centers. I mean, just building one data center is,
right,
enormous amount of work.
Yeah, and I mean, it's great to have that capacity. I just, can't even imagine just the effort, the ongoing effort of building and maintaining. And then, when you push out a software deployment and update, right? We're going to update a core feature of S3, or we're going to update a core feature of DynamoDB. How kind of terrifying that must still be, even with all their automated systems and their testing and their great development practices. How terrifying must it be when like literally half the internet relies on a service like S3, right? And what if something goes wrong? You have just broken half the internet because you did something wrong, which is pretty much what happened back in February of this year. A lead system administrator literally fat-fingered the number of indexes that were supposed to be dropped and rebuilt. And instead of 100, it turned into like 10,000. And it completely brought down S3, which brought down almost half of Amazon and AWS in the process. I would not want to be that person. It would not be fun.
No, definitely not. So what are common problems that come up with all this cloud stuff when you're doing programming with it, and how can you avoid them?
So I talk about this a little bit in the presentation. The common problems really resolve around failure, right? And you can talk about vendor lock-in. I don't really believe all that much in that argument, although some people certainly do from a very strong kind of moral, philosophical point of view. I think the biggest issue you're going to run into is failure. What happens when things go wrong? What happens when S3 goes out? What happens when DynamoDB goes out? Now, these don't happen often. The S3 outage that happened back in February was the first time in 4 years that S3 had any sort of serious major extended service problem. But you have to have a plan. That plan can just be blame Amazon and be like, head in the sand and we're blaming Amazon. It's their fault. It's what a lot of people have to do with cloud service providers, right? You have no other choice because, building that kind of replication or building a backup system can be incredibly expensive, right? The reason why you go with Amazon, you go with Google, or you go with Microsoft is because they built these systems already. You don't have to make that investment. So it could be just blame Amazon, or it could be that you should think about better caching strategies, right? Back pressure. If you notice, if you're pinging the service and it's down, then you say, okay, we're going to shut off these features of these services, or we're just going to pull everything from the cache rather than pulling live real data. Can your business handle that? Can you turn off ordering for an hour or two when this goes on? These are all questions you have to ask yourself. And it's really just about having that plan and understanding the trade-off between full, 99.999999999% uptime and the cost of that kind of uptime. Because for most people and most businesses, that cost is simply too great and too significant, considering that outages are really, at least on AWS, quite unusual.
Mm. So that's kind of a friendly degrading of the functionality in your app. Maybe
right.
The image recognition part doesn't work, but other bits continue to work.
Absolutely. I mean, I'd imagine you have local copies of your data, your core data, you're caching things locally. If you're using e-tags on the images, on your pages, those can be cached in the browser for quite some time without ever having to go back to S3 or CloudFront or any of their services. So yeah, it's really just being a little bit smarter about how you look at either caching or degrading the services that you offer on your website.
Anything else you want to share with listeners about using AWS or other cloud stuff from ColdFusion? Or?
I think one of the things that keeps people away from doing this is that it sounds scary and difficult. It's not. Like I said, I think, with AWS and even, other, I've used some stuff with Google Cloud before. It's simple. The SDKs they provide are super simple. And I know that people sometimes get freaked out because it's like, oh, it's the SDK for Java and I have to write Java. I have to know about Java. Well, if you know a little bit about how objects work in OOP languages like Java, if you know how CFCs work, you can pretty much figure out the whole Java SDK. Every method is very clearly explained. In the docs, it says this is what's expected. This is what it returns. And, CF dump is your friend. Write dump is your friend, right? If you don't know what the methods are on the object, you write out, you're like, oh, this is what I'm looking for, and this is what this method is looking for. And yes, it can be a little verbose sometimes, but again, the power that it provides you, just because something's a little complicated to learn at first, and I wouldn't even say this is all that complicated, it's pretty straightforward. If you know how to read the docs, you can figure it out. And there's lots of examples on their blog and in Stack Overflow because people use the Java SDK for AWS a lot. Just because it's a little different, and just because it is Java, doesn't mean you shouldn't use it, because the benefits are so powerful and so enormous, and what you can do with that. I mean, like, again, the thought that we can talk to, Lambda, and we can write stuff in JavaScript in Lambda and talk to it from CF with, so few lines of code. I mean, it's like 5 lines of code to invoke the function and to get it working and get the data back from AWS, and to have this whole infrastructure in the background that we never had to build and we can just tap into, is so great and liberating, and it's fun. That's the other thing, is sometimes development isn't fun, right? And people make the argument that ColdFusion isn't fun because it's an old language. It's not as fun as Node. Well, you know what? If you tap into a service like Lambda, or if you tap into, OpenWhisk on IBM or Google Cloud Functions, and they all run Node, you can have that fun. You can do that fun and discover the joy of polyglot programming and staying current and doing new things. And I think, that's the thing that I hope people walk away from my presentation with, is this some sort of inspiration about going out and trying it out, because it's not hard and it's really fun and incredibly powerful at the same time.
Great. Well, good luck with your presentation at CF.Objective. I'm going to change gears a little bit.
Sure.
Yes. So why are you proud to use ColdFusion?
So I love the fact that I can be super productive in ColdFusion in a very short amount of time. So, for example, I had to, I get requests for lots of data, and I teach a class here at Johns Hopkins, which is a prerequisite class to all the incoming students at the School of Public Health. And people keep sending these Excel files, and they're like, okay, can you tell me if these students took your class? Can you tell me if these students... It's a pain in my butt. It's tedious, it's boring, it's repetitive, and the spreadsheets are all different and they're never quite the same. And I'm like, okay, fine. You know what? I'm just going to finally just write a tool that will let me read the spreadsheet regardless of the columns, match on various columns, blah, 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 blah. I knocked that thing out in about 5 hours, because, including all the testing and everything, because of CF spreadsheet, right? That functionality is built into ColdFusion. I don't have to go find a library, figure out the library, add it all in. Is it still supported? Does it work with JDK 1.8, versus 1.7? I don't have to worry about all this stuff. I can be super productive, super fast. And that's one of the reasons why I'm proud to use CF, is because it makes me a more productive developer. And when I want to go outside of CF, it's really easy for me to have CF talk to something else, regardless of what it is. For us right now, it's a lot of Node apps and Node services. CF talks HTTP. HTTP is the lingua franca of the web. It's the lingua franca of Amazon Web Services. Amazon Web Services, everything you do in it is an HTTP request. Even if you're using the AWS SDK for Java, it's making HTTP requests in the background. ColdFusion is part of that, and I can be super productive and I can talk to those languages and be a polyglot programmer, because I don't have to spend tons of time, when it comes to fun stuff like spreadsheet or PDF generation, dealing with horrible libraries. I can just make it happen within CF within a couple of lines of code, and I love that.
That is great. So, sometimes people read that ColdFusion is dying, and that blog post has been floating around in different flavors for so many years. It's ridiculous, because obviously it hasn't died.
Right.
But what would it take to make ColdFusion more alive this year?
So that's a really good question. I mean, aside from people being out there and saying, hey, I'm using ColdFusion with this thing, or I'm doing this in ColdFusion, these cool projects, I'd love to see more projects highlighted by Adobe and Lucee. I mean, I know that their time is limited, and especially Lucee, since it's no open source product, who's really going to go out and evangelize for them when they don't have full-time staff necessarily to do it? Although I think the Ortis team does an amazing job of evangelizing CFML. They really, really do, and I'm very thankful for everything that Lewis and Brad and Gavin and Eric and everyone does who's on that team, because they really bust their humps trying to promote CFML. But I would love to see more, marketing or highlighting of what you can do with CF. I really would. I think people think it's a dead and dying language, but now, people are saying, oh, Ruby on Rails is dead and dying. Why are you using that? It's so old. It's from 2 years ago, right? When, 2 years ago, I was like, you're using ColdFusion, you should be using Rails. It's the best thing ever. And now it's Express and it's Node and whatever else. So from a developer perspective, I would love to see better official tooling support. I know there are certainly add-ons that are out there. Certainly the Ortus team does a lot with TestBox, which is critical and important. But I feel like Adobe could do better with the tooling around CF itself. The language, I think, is pretty mature. The language is fine the way it is, especially in CF script syntax. I think by now in 2016 they've worked out a lot of those issues. At least Adobe has, and certainly Lucee has. I would like to see better tooling and support. I would like to see the app server spin up in like 2 seconds, like a Node environment can spin up in like 2 seconds, or a Ruby environment, a Rails environment can spin up in a matter of seconds. Doing testing and waiting for everything to spin up is one of my big developer time blocks. But again, people see that and it's like, well, the ColdFusion app server takes 30 seconds to start up. When I do something in Node, it takes 2. That adds up over time and gives a perception about what ColdFusion is and isn't, and is it a dead and dying language because it takes so long to start up. So that would, addressing some of those tooling issues at the core would make it better, I think, for the entire community and make people say, yeah, you know what, this is an equally viable language in the same way that Node is, or that JavaScript/Node is, as well as Ruby, as well as Python, as well as really anything else.
Those are some great suggestions for making ColdFusion more alive this year, and that's part of my mission with this podcast to, get people enthused about it and seeing ColdFusion is a modern language if you use it right.
Absolutely.
And just to address the faster server spin up, I was in a discussion with Gert at Into the Box, who's one of the Lucee folks, and he's been working on speeding up the spin up time. I don't know what number of seconds he's got it down to, but it's. I think he started at 8 seconds and he was trying to improve on that. Whether he got it to 2 seconds, I don't know. But
that's pretty amazing.
Yeah, because if you're using command box or some other way to just call stuff, you need it to spin up fast.
Absolutely. Absolutely.
Yeah. So with CF.Objective coming up in just a few days now, what are you looking forward to at the conference?
So number one, okay, here's what I'm looking forward to. I'm looking forward to the speakers because I know quite a few of them and they're wonderful men and women and they're cool and I like hanging out with them and I like to harass Gavin Pickin among other people. They're great. They're also a lot smarter than me. The thing that I love about CF.Objective and the reason why I've gone to the conference, I don't know how many years in a row now, maybe this is like my 8th or if this is the 8th CF.Objective, I think I missed the first one, is because they're people who are so much smarter than me. And I always learn so much from them as individuals in their sessions. One of the things I like about CF.Objective is that it's CFML sort of oriented, but there's a lot more than that, right? There's a lot of stuff about the front end. There's stuff about Docker. There's stuff about GraphSQL, or GraphQL, excuse me, which I'm looking forward to learning more about from some really smart, really good presenters. And I've seen these people present before many times. They're super smart people. And I always feel like, even as someone who's been doing this for a long time and who gets to present too, I learn a lot. And they're approachable people. That's a really nice thing. I talked about the AWS conference in the beginning. It's hard to network with 40,000 people. Right? Even with 2,000 people, it's
just slightly.
Just slightly. But at a conference the size of CF.Objective, I can meet and I can talk with people. I can see people in multiple sessions on the same topic or different topics, and we can talk or we can have lunch together. It's much easier to network in that smaller environment, particularly with the other speakers. And I think that's one of the great advantages of a small conference is you really do get those opportunities, even if you are not the best sort of most self-promoting networker that's out there. Even if you're a pretty sort of introverted person, you can just sit down next to somebody and strike up a conversation because you have a shared topic to talk about, and that's the sessions that you saw that day.
And if that doesn't work, you can always do it over the networking events. Which,
that's right. There are those as well. Exactly.
So if people wanted to find you online, Brian, what's the best ways to do that?
Well, probably Twitter and GitHub. So I'm at github.com/Brian Klaas, all one word. On Twitter, I am Brian_Klaas. If you tweet at Brian Klaas, he is a political professor over in London who's my doppelganger apparently now, whose tweets now somehow he bashes Trump all the time. He's left-leaning. He's very outspoken critic of Trump. And so it's very bizarre. In my Twitter timeline, my name just keeps reappearing and reappearing because other people that I follow him and retweet his stuff. And I'm like, no, I was there first. I just accidentally put an underscore in my name. I don't know why I did that. I never should have done it. But yeah, so Brian_Klaas on Twitter, and then Brian Klaas, all lowercase, all one word, on GitHub are probably the best ways to see my work and, of course, to get in touch with me.
Great. Well, thanks so much for being on the podcast, Brian.
Thank you, Michael, very much. It was great. I had a great time.